Girls, I want to go over the worksheet. So if you haven't, get it out. If you don't have it, I'd say jot some notes down. Again, we are on our adventure of reviewing for this test that's coming up on Friday this week. And it's a two-part. Thursday will be a work with each other part, and then you'll submit it on Friday. God bless you. And then Friday will be you do it on your own part and submit it after class. Sound good? I would strongly encourage, if you feel that you are somebody who would want more time on the Friday portion, I would strongly encourage you to take care of it that day, whether it be before school in the office right over here, right across the hallway, or if you're out first period, or the rest of the day I'm over in that office over there. So I would strongly encourage you, if you feel that you think you might need more time, take it upon yourself in order to do it. It's not that long. It's a front, back. And when I say front, back, it's like, here's a problem, because the graph is this big. And then another problem. So it's like maybe 2 or 3 problems on a page. So it's not, extraordinary amount of problems to do. But I just want you to make sure that you have the time. You don't want to take, over fall break or spring break. You don't want to, totally space it off and then you come back next week or the week after and say, oh shoot, I forgot. Also, there's a couple of you that still need to get over to the Math Science Testing Center because there are tests over there that need to be completed, okay? So, and again, you should go by, take a look when the hours are that they're open, verify, take it upon yourself that if they say, hey, we're busy right now, can you wait a few minutes? Then that means they're busy right now and you need to wait a few minutes. They can only take like 10, 11, 12 kids at a time to go through testing. That has to do with all the math and all the science people as well. So take it upon yourself. All right, let me go through these problems. This is from worksheet number 13, not just number 13. Angelo. But we're going to go through and make sure we know how to do it. Does anyone need a picture of it before I start going over it? If you do, I'll come by and you take an 8x10. If not, I'm rolling. All right, the first 9 problem says, graph the following, use a 1 through 5 rule. Be sure to label the 4 key points, vertex, roots, y-intercept. Okay, so this particular problem, it's going to have a vertex at 0, 4. How did I get there so fast? What value am I missing? What do you got, Steve? Yeah, I'm missing the p-value, right? Good. Does that make sense? So if the p-value is gone, that means that the x component of my vertex is 0. That means I plug 0 into the x's, and I wind up with a 4. So I get a vertex of 0, 4. That 0, 4 means a couple things. That's the vertex. What is it also? Crosses where? Y-axis. Okay, so in this case, the vertex and the y-axis are the same thing. I'm going to graph using the 1, 3, 5 because there's a 1 out front there. I probably won't be able to get too far on this because I'm already shifted up a little bit. So I'm going to go right 1, up 1, left 1, up 1, right 2, up 3, left 1, up 3. There we go. And there it is. That's what that problem looks like. Did we label? So we don't have any roots because it doesn't cross the x-axis. The y-intercept and the vertex happen to be the same thing. And that's not, honestly, if you got to that point, I'm pretty sure you understand where the vertex is. Agree? If you've graphed it and it shows where the y-axis is, see how I have dots there? Make sure I can see dots. Okay, I don't know if we necessarily need to worry about going in through and saying these are ordered pairs, saying, oh, this is 0, 4, this is 1, 5, this is negative 1, 5, this is 2, 8, this is negative 2, 8. If you put the dots appropriate, I should be able to see as the grader to go through it. May I move off this problem? All right, next problem, I get y equals 2x squared minus 8x plus 2. So let's find the vertex first. So I'm going to do negative, negative 8. Why is it negative, negative 8? And why is it negative, negative 8 over 4? Yeah, it's negative 2a, or negative b over 2a. So the negative already comes place, and now I'm going to plug a negative 8 in. So I got negative, negative 8. Negative, negative 8 is positive 8. Agree? 8 over 4 is 2. So then I need to plug 2 into my x values. So this is going to give me 2 squared, which is 4, times 2, which is 8, minus 16 plus 4. Does everyone see where these numbers came from? Shh. Okay, so 8 minus 16 is negative 8. Negative 8 plus 4 is negative 4. So I get 2, negative 4. It's not going to grow at the rate of 135. It's going to grow faster. It's going to go twice as fast. So it's not going to be 135. It's going to be 2, 6, 10. Right? So let's grab that. So I'm going to go from here. I'm going to go right 1 up 2. Left 1 up 2. From there, I'm going to go right 1 and up how many? Put the phones away, please. Don't blame Mac. All right. Vertex obvious? It crosses the x-axis, but are there roots to it? Crosses the x-axis, but are there roots to it? What do you think? I mean, I could go through, I could try and factor this out. So I'm going to get 2x squared minus 4x plus 2. What two numbers multiply together to give me 2, add together to give me negative 4? Nothing. So do I know my roots? Do I know where it crosses here and here? Exactly. No. What are they called then? Irrational. Irrational. Okay? So I have irrational roots. Shh. Can you see where it crosses the y-axis? Yeah. Where's it at? Give the 0, 4. Cool? So that's about how you could run through that problem. Next. Let's see. I can graph all 3 of these. Let's see. I'll do this one in black. This is already, or in blue. That's in vertex form already. What's the vertex of that one? Negative 2? Negative 2, negative 5. Good. The vertex is negative 2, negative 5. Okay? So negative 2, negative 5 right here. How fast will I grow? Will I grow 135 or will I grow different? What's the number right here? 1. So what am I going to grow at? 135. Right 1 up 1. Left 1 up 1. Right 1 up 3. Left 1 up 3. Okay? Can I see where this one crosses the y-axis?
No. Yes.
Yeah, it's right there. It looks like 0, negative 1. I would say here and here are irrational roots because this one, if they're not going to cross right away. I mean, because I'm going right 1, right 1, right 1, right 1. So it's not going to show that crossing. You know, if I went right 1 from here and then up 6, it's definitely going to be somewhere in the middle. So that's the first one. Let's do this. Do this one in red. Where's that vertex? God bless you. Negative 3, positive 2. Okay, so negative 3, positive 2. It's right there. What rate is this one going to grow at? 135. The lead coefficient right here is a 1. So right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. Right 1 up 5. 1, 2, 3, 4, 5. What point would that be? 11. All right, so can I see the vertex? Yes. Can I find where it crossed the y-axis? Yes, it's going to cross at 0, 11. Okay, if you don't trust me on that one, you can multiply this out, x plus 3, and then whatever the answer is, add 2 to it, and then your constant will be at 11. Okay? Are we good so far?
Yep.
Hey, are there roots to this problem? They're not irrational. They're actually the other one. They're what? Complex. Good. Not real. Okay? They don't cross the x-axis at all, so they are not real. They are called a complex solution. God bless you. Boy, today, you can tell things are growing in the air. Everyone's sneezing today. All right. Last problem on this page. What's my vertex? 4, negative 3. Good. What rate am I going to grow at on this one? 1 through 5. So 4, negative 3. 1, 2, 3, 4. 1, 2, 3. And I'm going to grow at run. Right 1 up 2, 3. So I can see the vertex. Oh shoot. How are we going to find where it crosses the y-axis? I mean, I could go right 1 and up 6, and then right 1 again and up, or up 5 and then up 9 if I wanted to. Or let's do this. Negative 4 times negative 4. Negative 4 times negative 4. 16. 16 minus 3. 13. So this one would have crossed up here at 13. I didn't really have to multiply the whole thing together to figure it out. I took the constant, squared it, and then added it or subtracted it from that left part. That's those 3 problems. This one has irrational roots. I don't know exactly where it crosses the x-axis, but that's okay. This one, if I multiplied it all out and subtracted 3, it would not have factored, and that's okay. Okay, let's try these two. Negative b over 2a, negative b over 2a, negative b over 2a. For negative b, that's positive 4 over 2. Is it positive 2? Positive 2. Plug 2 squared in, so I get 4 minus 8 to negative 4. Does that make sense? I'll go back through it if you need me to. 2 negative 4. Does everyone feel okay with how I just went through that?
Where'd you get the 2?
Okay, negative b over 2a. So that's negative negative 4 over 2. So negative negative 4 is 4 over 2. 4 over 2 is 2. 4 over 2, yeah, right? Does that make sense? And then get the negative, plug it in. All right, how fast is this one growing? 1 through 5, the lead coefficient's 1, so I'm going to go right 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. Can I see where it crosses the y-axis? What's the point? 0, 0. Can I see where it crosses the x-axis? Yeah, it crosses at 4, 0, and it also crosses at 0, 0. So my roots are 0 and 4. Okay, they're real. I know where they fell. The pattern graphing found it pretty easily. Sound okay so far? Moving on. You guys taking the notes you need to take? All right. This one. What's my vertex? What's my b value first? 0. So what's my vertex? 0, comma? 0, comma 1. Awesome. Good job. 0, comma 1 is right there. What's the rate this is growing? Gauge. It's not this. It's going to be negative 3, negative 9, negative 15, right?
Yep.
I probably won't have to use them all. All right, so I'm going to go right 1 down 3, left 1 down 3. From there, I'll go down 9. That's kind of too far. Can I see exactly where it's crossing the x-axis?
Yes. No.
No, so it must be irrational. Okay? Where does it cross the y-axis? At 0, 1. I can see the vertex also at 0, 1. Good problem. Okay, these are both the vertex form. What's my vertex of number 8? 3, 1. 3, negative 1. Good. 3, negative 1. 1, 2, 3. Negative 1 down here. It's growing at what rate? 2, 6, 10. So I'm going to go right 1 up 2. Left 1 up 1 or 2. Right 1 up 6. 1, 2, 3, 4, 5, 6. Left 1 up 6. I can see the vertex. I can't really see where it crosses the x-axis exactly, so they are what kind of roots? Irrational. 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 All right. Okay. Uh-oh. Where is this going to cross the y-axis? Let's see if we can figure this out. Negative 3 times negative 3. Positive 9 times 2. 18. 18 minus 1. 17. So way up here at 0, 17. Let me run through that one more time. Negative 3 times negative 3. Positive 9. Positive 9 times 2. 18. 18 minus 1. Positive 17. All right. Second problem.
For the 1/2, would you go up by half and 1/2?
So here, let me put that real quick. Are you okay with the vertex?
Yes.
So I'm not going to grow at 1, 3, and 5. I'm going to grow at half, 3 halves, 5 halves. You see how I just got that? Okay. Does that make sense? So let's get the vertex first, and then we'll figure out the rest. Negative 1, 2. Negative 1, 2. So I'm going to go right 1 up half. Left 1 up half. Okay? God bless you. 3 over 2 is the same thing as 1.5 or 1.5, right? Okay? So 1.5. So from here, I'm going to go right 1 up 1.5. Left 1 up 1.5. That's kind of weird. It's fatter. If that fraction is between 0 and 1, it's going to be a fatter parabola. This has a vertex I can identify as 0, 2. It looks like it crosses the y-axis at 0, 2.5. Would that make sense? Yeah. Is it crossing the x-axis at all?
No.
No. So they are not irrational, but they are complex. Good. We doing all right? So that's the front page, right? Then the back page, 13 and 14, it says, for each graph, identify the range, the vertex, the maximum or minimum value of function at x. Give x values in which function at x equals 0. E, the intervals of x where function at x is increasing. And F, the equation of axis of symmetry. Okay, I think we can do those. So here's our graph. All right. So the range of this graph appears to do what? Do what? It's going down, so it's going to negative infinity. Where did it start at in the y direction? 1. So my range on this problem is going to go from 1 to negative infinity. Hey, and I'm using a square bracket at the 1 because I'm including that point. I'm including this point and going down. Okay? The vertex appears to be what? 1, 1. As a point. Is the vertex a maximum or a minimum? It's a maximum. Remember, the maximum goes with the y component. So what is my maximum value? 1. So it's a max, and it's at 1. Where does the function at x equal 0? This means the roots. This means the x-axis. Where is it crossing at the x-axis? 0 and also 2. So it's crossing at 0 and 2. Those are our roots. If I wanted to make it points, I'd go 0, 0, and 2, 0. Okay, but it's asking for the roots. Where it's increasing. So remember on these graphs, we have that. That's not going to be the best of colors. We have that. And that. Pink or black increasing? Pink is increasing. It's increasing from negative infinity all the way up to the vertex 0, 1, and it closes. So this is not a square bracket because I do not include the vertex. I approach it. So the pink is increasing, the black is decreasing. If the parabola is open upward, the increasing, decreasing flip-flop each other. But we'll get to that on another one. Axis of symmetry. Axis of symmetry. Give it to me as an equation, though. X equals 1. Awesome. X equals 1 is our axis of symmetry. I love it. Okay. So, hang on. Let's kind of breathe for a second. Let's shake it off for a second. Let's make sure we're okay. So, we're talking about a lot of stuff. The vertex is either the high point or the low point of the parabola. The parabola on one side of the vertex is increasing, on the other side is decreasing. Okay, there's some sort of intervals. When we're talking about a maximum or a minimum, you're talking about the vertex, but you're talking about the y component of the vertex. The range talks about the y component of the vertex, whether you go up to infinity or down to negative infinity. Okay, there's a lot of things that do take place with these. So the verbiage is kind of hard. I would strongly encourage a good way to get things down to know is create a flashcard. Okay, literally a 3x5 card. I have some in my office, happy to bring them over. If you have an interest in grabbing them, just so you get the verbiage down, because when, you know as well as I, when you're looking at your test and you're like, oh shoot, the range, the range, the range, the range, the range, the range. Smiley face. That was me making fun of how some of you act like you're gathering your thoughts. You're looking around. And shame on you. Now you get the person sitting there going, how did he know I was doing that? You know, I got caught cheating once on a math test. Freshman year. So I was your age. So I sat about where Mac was sitting in a classroom at Marcos Deniza High School. Jenny Tucker was right in front of me. So Jenny is kind of doing this, just checking over her test. So I did this, and guess what? Mr. Worthy knew. So I do one of these. Verifying my work. Mr. Worthy was sitting at the table right about here. He had this long ZZ Top beard down to here. An old Vietnam vet, kind of this rough voice, smoked like 19 packs of cigarettes a day. So I go to hand in my test. I hand it, and so act like you're handing me something. So I'm handing it in. He grabs my wrist. And he's holding my wrist like this. And I'm still holding a piece of paper. And he goes, I saw you looking at Jen's paper. And I'm just at the point where I'm like, I'm feeling uncomfortable. Because everyone now's eyes are on me. And he's kind of holding my wrist. And you get a 0 for the test. You know what stunk? My answers, without changing anything, matched Jenny's. I had done really well on this test. I got a 0 on it. Man, it stunk. So I got caught cheating. I tell you what, he scared the daylights out of me after that. I mean, I didn't want to look in his eyes. I walk in class, hey, how you doing? Just pass me by. I'll watch the class from outside. I don't need to. All right, sorry about that. Oh, hey, new problem. Okay. So guys and girls, I haven't always been this, straight and narrow guy. I looked at Jenny Tucker's paper. You know what Jenny Tucker does now? She's also a math teacher. I don't know what about that class. All right. Range. Oven. Stove. What? What? -1 square bracket to infinity. Good job. Was that Preston?
No, that was me.
Oh, okay. Good job. You threw your voice well. Ventriloquism. Vertex. -3 what? -3, -1. Is our vertex a maximum or a minimum? Minimum. It is a minimum. What is my minimum value of this graph? Remember? -1. Good. Where is the function at x equal to 0? -2 and? -4. Okay? If we wanted to ask it as a point, it would be -2, 0, -4, 0. Increasing and decreasing. Increasing and decreasing. Let's see if we can do that. Are we increasing with pink or black? Black is increasing. Where is it increasing from? Negative what? There you go. -3 to infinity. Now here's where the confusion starts setting in. Why am I saying -3 when the -3 is an x value and we're looking at where it increases, not the y value? Because what basically happened, and you'll see this later, it's called a sign line, and they want to know where graph is increasing or decreasing. All you're doing is looking at the x-axis. Theoretically, you have a y-axis that you could put in there and say, oh, the graph's doing this and it's above the graph, or it's increasing or decreasing. Axis of symmetry. X equals -3. Fantastic. X equals -3. Love it. Okay? We doing all right?
Wait, so the if x equals 0, is that just us with the
Yes. Yeah, it's just a different way.
That trust me a lot.
All right. Are we ready for the last two problems? Last three problems, excuse me. Yep. They're all on one page. Here we go. All right. These said, hey, given the x-intercepts of the parabola, write the factors of the quadratic equation, then multiply to give you the equation. All right. So this gives you x equals 0, x equals 2. Still with me? The binomial is x plus 0. The binomial is x minus 2. Where did that come from? What's x plus 0 the same thing as? X. So if I multiply them together now, that's your binomial. That's your quadratic. That'll be, so I guess you could put y equals in there. Okay? This is x equals 3. X equals -6. Still with me? This gives me x minus 3. How did I get that? I subtracted 3, brought it over. And this one's going to give me what? Good. We're going to multiply together. Combine like terms. So y equals that. This is x equals -4. X equals -2. So x plus 4. Shh, almost done. X plus 2. Multiply them together. Combine like terms. What do you think? Feeling okay? So I gotta figure out how to make this work appropriately. Okay, so today is Tuesday, correct?
Yeah.
In which I have the video that'll be put up on YouTube in a little bit for, what we just went over. I'm also going to have you do another review for tomorrow in which we'll do the same thing. We'll go over it in class, but then be another review on Wednesday. Now here's my problem, and it's your choice. You tell me what to do. I will not be here on Thursday. I'll be here on Friday though. So during Thursday's class, it'll be the work together portion of the test, and then Friday will be we're individually. So on Wednesday, so basically from Wednesday to Thursday, I would have a review assignment for you, but there's no way for you really to check to see if the review assignment, you did it correctly. Do you want me to make another video tomorrow to go from, so I can make tomorrow's video, and then I'll make another video on top of that, which will be actually Wednesday going over, so Thursday you come into class. Raise your hand if you want that video for, at least one, this works for me. Okay. So what I'll do is, today we'll have today's video go up there, and then I'm going to get you the assignment, which we have about 15 minutes to work on, which is awesome. And then tomorrow I'll go over what I just gave you today, and then I'll give you another review, but I'll make a second video tomorrow in order to go over it. Is that all right? Sound good? So what are you going to do if you think you might be that person who might need more time on Friday?
Watch the video.
Okay, you can watch the video. Come in the morning. Come in the morning. If you're off zero period or you're off first period, I'll be in the office across the hallway on Friday morning. Or after this class, make sure you get it taken care of. Don't let it get behind you. Don't let 9 days pass and then you have the week after break going, oh, darn it. Oh, let's use the big term. Oh, fiddlesticks.
Whoa!
Hold back. What happened?
He did a spider on his leg and threw it in. It wasn't a spider. It was like a big, I don't know what it was.
You jumped that much for a spider? Ray, what is wrong with you?
It was super fun. You put the spider on TJ's
All right.
Stay with me if you guys reactions.
All right. Your assignment for next time, which we'll go over in class, is worksheet number 14, which is page 77, all the way through 80. So guys and girls, it's your review. If you're going to do the review, awesome. Does anyone need to take a picture of these? I'll come to you. Huh? Tomorrow.